Okay, let's look at some more at what we're doing in this argument. Erase this underline. Some more at what we're doing in this argument. Okay? You're given three premises and a conclusion. Okay? I'm telling you it's a valid argument. Okay? You have to show that it's a valid argument by deriving the conclusion from the premises. Using what relation? Logical implication. Okay? Okay? Using logical implication to derive it. How do you determine what's logically implied by the premises? Argument patterns. Argument patterns. P or Q, not P, therefore Q. There's one argument pattern. Okay? And now all of our argument patterns are two premise patterns. So you're going to look at two of the propositions. You have more, right? But often two propositions together are powerful enough to imply something else, right? If you didn't have premise 2, you'd still have A or B and not A. And those two premises together would imply B. Okay? So you get to this conclusion by drawing as many inferences you need from the original premises in order to reach the conclusion. So you're always going to be looking to see what two lines reflect one of the patterns we've seen. Okay? So a good way to tackle this is you have an or statement, you have half of it denied. That reflects this pattern, this MTP pattern. Okay? So I conclude that based on premise 1 and 3 together, that B is true. That B is true. Okay? Notice this has to do with our chapter 1 stuff too. How do I get B? I'm assuming these premises to be true. If all these premises are true, what else is true? First of all, B. I can't use my rules to directly deduce C yet. Okay? So this is a multi-step thing. But what is B? B is a valid inference that is logically implied by these premises. In particular, it's implied by premise 1 and 3. How do I know? Because it follows the MTP valid pattern. When you have a disjunction and half of it, the disjunction is false, it follows that the other half is true. So now B is something logically implied by these premises, which means I can appeal to this as well as these initial three premises to draw further inferences. And that's often going to be how this works. It's going to take multiple steps, and you're going to have to now reason with this, right? And now think of how that goes intuitively. Since either Ann or Bob is here, but Ann is not, Bob must be here. Oh, and since Bob is here, and Bob implies Carl, then Carl is here. Okay? So this reflects how our own reasoning usually would go with this. Keep stepping out of the camera today. I don't know why. I'm trying to give you a full view of the board. Okay? So now what is this, right? This goes sequentially, right? 5 is an inference based on some of the premises, some of the lines 1 through 4, right? We have the three initial premises. We have B, which we deduced from these initial premises, and then we went on to deduce C. From which lines? Lines 2 and 4. Using the modus ponens pattern. Now notice, I still only use 2 lines here, right? Some of you get tempted to follow that like 2-step process. Well, I got B from lines 1 and 3, and then I got C from 2 and 4, so it's 1, 2, 3. No, don't do this. Don't do this. Each inference takes 2 lines following one of the patterns. 2 lines following one of the patterns. Okay? So once you have 1, 2, 3, and 4, you can deduce C using lines 2 and 4 and the modus ponens pattern. Okay. All right. That's the procedure. We're going to do some practice, but first I want to talk about recognizing the patterns, right? Even when we don't get, see these, I've kept it simple, right? P converts over to a capital letter. Q converts over to a capital letter, right? But there are more complicated instances where you still have to recognize the pattern, especially things can get tricky with negation. I'm going to give this a video on that, and then we're going to do some practice.